Hello everyone, I'm Stephanie and welcome back to my channel Math Specs. Today we're going to work on our practice set for section 1.5 where we learn to translate phrases and sentences. Today we're actually going to kind of recap what we learned last time and learn a little bit more about translating sentences into equations. So last time we learned how to translate phrases into variable expressions. So now would be a really good time to review what a variable expression has. And if we remember, a variable expression has three components. It has an operation, so that would be like addition or subtraction, multiplication. Let me actually rewrite this. This looks terrible. So it would be an operation. So what are some operations that you know? You know addition, you know subtraction, you know multiplication, you know division. So those are operations, okay? Variable expressions also have these fancy things that we like to call constants, and those are just numbers. So 1, 2, -1, maybe 0. Um, Fractions, definitely, decimals, and they also have variables. So what are some variables that we discussed? Variables are just letters that we kind of designate for numbers to represent numbers. So usually our most popular ones, it's X, Y, Z, S, or T. So that's a good review about a variable expression. A variable expression will have an operation, it will have numbers, and it will have variables, okay? So last time we learned how to translate phrases. Remember our vocab, our addition vocab, our subtraction vocab, multiplication vocab, division vocab. So that's what we learned last time. Today, we're going to be learning how to translate sentences into equations. And if you actually remember, we also discussed the definitions of an equation. So equations are just variable expressions with an equal sign in the middle. So let me go ahead and demonstrate this for you. So an equation is going to be a variable expression to the left-hand side and to the right. So we're going to have a variable expression here and a variable expression here, and we're going to separate them in the middle with an equal sign. So let me give you an example of that. So I'm going to just make something up. I'm going to say my variable expression is 2y plus 1 is equal to 5, or 2x plus 3 is equal to 2.5x, something like that. We have variable expressions on the left-hand side and variable expressions to the right-hand side. And because we have this equal sign in the middle, it's an equation, okay? So today we're going to learn how to translate both of them. So if you recall, last time we discussed things like 10 times a number, where times was actually our vocabulary word, and it told us that we were multiplying that. We would have a product of 10 and a variable, and this is how we would write it. 10 times n, and we just designated n to be our variable, but it could be 10x or 10b, 10c, stuff like that, okay? The next example, let's see. We also discussed things like 3 less than a number. Recall that less than is actually a vocab word for subtraction, and that order does matter in subtraction. So 3 less than a number is going to be n minus 3, whereas something like 3 minus a number would be 3 minus n. So go ahead and check out that lecture just so that you can kind of understand the order. Um, so let's see. So recall that equations are statements that are created by placing an equal sign between two expressions, and we just discussed that. So the sum of a number of x and 12 is 6. So the is right here is really important. This right here is telling us that that we will have an equal sign. Okay, separating this from this. Notice here, x plus 2 is equal to, this is our is, 6, and this is our left, this is our right, okay, and the equal sign is what is separating both of them, okay, and recall the sum tells us that we're adding them, so that's why we have an addition sign there, okay. So let's go ahead and clear this. Okay, so let's go ahead and try it. We're asked to write the sentence as an equation. So we're going to take everything that we learned from our previous lecture on how to translate phrases into mathematical symbols. So we're kind of break it down. Um, so we're going to have something. Okay, so we have 10 times a number x is equal to 50. So I'm going to see 10 times, so this is times, so that tells me that it's multiplication, times a number x, this tells me my variable, and is right here tells me that that I'm going to have an equal sign, or is equal to 50. So let's go ahead and kind of break it down. So times tells me that it's multiplication. Is tells me that I'm going to have an equation, so I will have an equal sign. And a number, we're told, will be represented by the variable x. So this is how we would write it. We write 10 times a number x is equal to, we would write our equal sign, 50. Okay, it's pretty straightforward. Let's go ahead and move on to the next example. Here we are asked to translate into mathematical symbols the difference between 13 and a number is 7. And we're told that to let x represent the number. Okay, so let's just kind of break it down. So we have difference. The difference between 13 and a number tells us that there's going to be subtraction. A number, we're told to let x represent the number. So I'm going to write a number is equal to x. Is, I see it in this sentence here. The difference between 13 and a number is 7. So I know that I'm going to have an equation. So I'm going to have an equal sign somewhere between the difference between 13 and a number, and then that will be separated by an equation sign. So remember that order does matter for subtraction. So we have to really be attentive to how it's written because we can get a different answer. So we would write 13 minus x is equal to 7. Notice how this separates this and this side. So we have the difference of a number is 7. Okay. So we're going to move on, and I definitely encourage you to also break down all of your sentences or phrases like this. Write down any keywords or vocab words that you see, and write, to the right of them what they mean. Break down things like a number as, into the variable. Look for words like is, because it will tell you that you have an equation, that you have two variable expressions, one on the left and one on the right. And also this part right here where the order, it will help you if you write down your vocab word, because we know that for addition and subtraction, they have very different, um, for addition, order does not matter. But for subtraction and division, order does matter. So you have something like subtraction, you would be able to kind of have that next level of understanding if you break it down like this. So if you would say like order does not matter, so you're kind of building off of everything does matter. And so it's good to just kind of list everything here. And I would definitely encourage you to do that. Okay, kind of break it all down into the parts. Okay, so and here is an extra challenge. Check to see if x is equal to 6 is or is not a solution for 13 minus x is equal to 7. And this is a kind of a review of our previous section that we learned. So this was our lecture 1.4, where we were checking solutions for equations. Okay. So what you would do here is that you would substitute, you would simplify, so you would carry out the subtraction, and then you would make a statement if it is a solution or not. You say true or false, x is equal to 6 is or is not a solution for the given equation, okay? So we're going to continue. So we're asked to translate these phrases into variable expressions and again to let x represent the number. So beginning with our first one, we have a number increased by 11. So I notice here that I have increased by. That tells me that I have addition. I don't see an is, so and I'm also told in my directions that I actually have variable expression. So this is not going to be an equation. Okay, so a number increased by 11. So increase by means sum or addition. So this would be x plus 11 or 11 plus x. In our next example, we have the product of 11 and a number. So we would have, I'm going to underline product. That tells me that I have multiplication and 11 and a number. I know that a number is going to be x. So I also know that for multiplication, order doesn't matter. So our answer would be, or our product tells us we have multiplication. So our answer would be 11x. Okay. So now we have this example here. So we're asked to translate the phrases into variable expression and let x represent the number. So we have the quotient of a number and 11, and here I broke it down again. So I have a quotient up here, so I know that this is going to mean division. And does order matter in division? We said yes, it does. So where will the x and the 11 be placed in the fraction? So the quotient of a number and 11 means that a number or x, our variable, will be in the top, like right here. And 11 is going to be in the denominator, so that it'll be at the bottom. Okay, versus if we had the quotient of 11 and a number, that would look very different. It would be flipped. Okay. So here again, we're asked to write the sentence as an equation. So a number x is increased by 10. So I'm going to underline increased by because that tells me that I have addition. My variable is x, and so I'm adding x plus 10. So that will be actually my first. So I have a number x is increased by 10. So that would be x plus 10. Is tells me that I'm going to have an equal sign, and 24 tells me what will be on the other side. So this is what our answer will look like. But we're going to break it down. So we have is tells me I have an equation or an equal sign. Increased by tells me I have addition. So our answer would be x plus 10 is equal to 24. Okay. So going on to the right example, we have the product of 7 and a number. So we have the keyword product and of 7 and a number. So that tells me that I'm going to be multiplying 7 times x. And is tells me I'm going to have an equal sign. And 42 means that 42 is going to be on the other side of that equal sign. So let's go ahead and break it down. Whoops. So we can see everything. So we have is tells us that we're going to have an equation or an equal sign. Product tells us that we're going to have multiplication. And so therefore our answer 7x is equal to 42. Okay. Here we're going to translate the variable expressions and let x represent the number. So on the right we have the difference of 10 and a number. So I'm going to underline my keyword right here, difference of 10 and a number. And remember, for subtraction, order does matter. So I'm going to write 10 minus x. Okay, I'm going to say that that's my answer. But let's go ahead and break it down. So we're going to have difference tells us that it's subtraction. Does order matter for subtraction? The answer is yes. So our answer would be 10 minus x. Okay. Going on to the right, we have 15 increased by a number. I'm going to underline increased by because that tells me I have addition. I'm going to be adding 15 and a number. So I'm just going to write it down here. I'm going to say 15 plus x is going to be the final answer based off what I've learned. But let's go ahead and break it down further. So we have increased by tells me that it's addition. Does order matter for addition? No. So it could be 15 plus x or x plus 15. Okay. So that will be the end of our presentation for today. Next time we will begin the practice set where we will do more of these, translating phrases into variable expressions, translating sentences into equations. I highly recommend that you create flashcards for all of the vocabulary that we have learned in the previous lecture. I think they would be really helpful. Thank you so much for your time and attention. That is it for today, and I will see you next time.